All right, today we are going to be covering 3.2 slope-intercept form. And just as a reminder, if any point in this video you need to pause or rewind because I'm going too fast, feel free to do that. Slope-intercept form. Liam has $10 in his savings account and plans to deposit an additional $5 each week. Liam wrote the equation and created the graph to show the relationship between x, the number of weeks, and y, the balance in his savings account. Find the slope of the graph. Where do you see the slope in Liam's equation? So his equation's above the graph, as you can see, and we are going to find the slope. But remember, before we ever find our slope, rise over run, we have to recognize what our y-axis and our x-axis are counting by. So when we go up our y-axis, we need to make sure we are counting by 5s, and when we go on our run, we need to make sure we're counting by 1s. So our rise with 2 perfect points, or actually any point on this graph looks like perfect points. So we are going to go up 5 and over 1. So our slope equals 5, because 5 over 1 is 5. Okay, so where do we see that in his equation? It's the coefficient of x. So the slope is 5, and it is the coefficient of x. Where does Liam's graph intersect? The y-axis. Where do you see this value in Liam's equation? So I've got to erase a little bit here, but Liam's graph hits the y-axis here at 10, and it's the constant in the equation. So we would say the graph intersects at 10, the y-axis at 10. This is the constant in the equation. This brings us to slope-intercept form. Now, slope-intercept form, or y equals mx plus b, is a way to write an equation of a linear relationship. Now, if you're not sure what a linear relationship is, look at the first part of that word, line. All right, this is where m represents the slope, or rise over run, and b represents the y-intercept. So whenever x is 0, your y is your y-intercept, because it's where it crosses the y-axis. All right, use the definition of slope-intercept form to answer the equations. Now remember, slope is your coefficient. And I'm going to write that here, and I think you should too, because I'm going to be identifying the coefficient. And my intercept is my constant. So even if the equation is not in proper order with the x value first and the constant last, or maybe something is missing, I can still identify my slope and my y-intercept. So here, my coefficient is 2.5. So my slope, m, is 2.5. And my constant is a positive 4. So my b value that represents my y-intercept is 4. Now in number 2, I notice it doesn't have a constant. So I could add a plus 0, and that means my y-intercept is 0. So it probably crossed at the origin, right? Because it's 0, 0. And then my slope, my m value, is negative 1/7, because that's the coefficient of x. Now remember, with number 3, if I have a negative x, that means I have a negative 1 coefficient. So my slope would be negative 1, and my constant, my y-intercept, is negative 8. And number 4, we need to be careful because it's flip-flopped, but 15 is my constant, so that's my y-intercept, and my coefficient of x is 3/2, or 3/2. Now it says write an equation in slope-intercept form for each graph below. Before we start, I want to go ahead and find all my perfect points on this graph, because it makes our job a little bit easier down the road. So I'm going to place a point. Oh, that's a very large point. I'm going to place a point here and a point there. I'm going to place a point here and a point there. I'm going to place a point here and a point, let's see, there. Okay, now recognize I placed a point on my y-axis each time because it also helps me find my y-intercept. So let's start there. My b value here is 18, here is 3, and here is -2. My m value is my slope, so I have to recognize what my x and y-axis are jumping by. Here, my y-axis jumps down by 2, so 2, 4, down 4, and over 1. So my slope would be -4 over 1, which we could simplify to -4. Okay, in number 6, both my x and y-axis are jumping up by 1, so I can just count by ones. So I have 1, 2, 3 up, and 1, 2 over. Now you'll notice the 6 is kind of written in between two lines. That still counts, okay? The 6 is just a label for the line, so you need to recognize how many you're moving over. So my slope is 3 over 2. All right, now my last one, my x and y-axis are still just jumping by ones, so I can still count by ones. And remember, I start and I read left to right, so I'm going to go down 1, and over 1, 2, 3. So my slope would be -1 over 3. Rise over run. Now when I write my equations, I'm going to use y equals mx plus b, and I'm only replacing my m with the slope and my b with my y-intercept. Okay, so y equals -4x plus 18. Y equals 3/2 x plus 3. Y equals -1/3 x minus 2. Notice my slope is always the coefficient of x, and my y-intercept is always the constant. All right, go ahead to the back. In 8 through 10, plot the y-intercept, then use rise over run to plot the second point. Keyword, rise, then run. Remember, you can't get out of the bed in the morning, or you can't go for a run in the morning without getting out of bed. That's why rise has to happen first. Okay, draw a line connecting the points to create a graph of the linear relationship. So we always start on our y-intercept. Okay, plot the y-intercept. This is our starting point. So we are going to start on -4. We are going to start on +45. And this number 10 does not have a constant, so we would start on the origin, 0. That is where it crosses the y-axis. Remember, y goes up and down. And then we're going to use our slope, and we're going to go up to 1, 2, over 3. 1, 2, 3. And that's our second point. And we can graph our line from there. Okay, when I have a coefficient of x that does not have a denominator, remember any number divided by 1 is itself. And also recognize I still have to notice what my x and y-axis are jumping by. So my y is jumping by 5, my x is jumping by 1. Now this time I need to go down 5, because it's jumping by 5s, and over 1. So my second point would be here. And I could go down 5 over 1, down 5 over 1, so that I get a consistent line going all the way down, or you could use a ruler. Okay, number 10, we started at the origin, and our slope is -1 over 2, so I'm going to go down 1. Now you'll notice these are both 2. So when I go down 1, I either need to go down 1/2, or I need to go down 1 over 2, because -1/2 and -2 over 4 are equal. So I'm going to choose to go down 1 block over 2 blocks, which represents -2 over 4. Down 1 over 2, down 1 over 2, and I run out a graph. Now, just because I'm going down 1 over 2 doesn't mean I can't go in the opposite direction doing the same thing. So I could go up 1, left 2, up 1, left 2 as well. And this graph continues on and on in both directions. So remember that your graph, unless there's given a certain domain or range, your graph continue in both directions. So you may use the slope to go one way, but you also need to make a straight line that continues across your entire coordinate grid. All right. Now, the table shows a linear relationship between x and y. So we need to use our slope formula. Quick reminder, slope equals y2 minus y1 over x2 minus x1. And then we need to recognize our y-intercept, which has a y value of 0. Okay? So here, my y-intercept would be -3. And here, my y-intercept would be 35. Now, you might be asking, hey, Mrs. Kraft, how do you know that 35 is the y and not 0? How do you know money is the y and not the hours? Let's go back to our independent versus dependent variable. Hours control how much money you make, right? The amount of time you work controls the amount of income you have. So, when we're thinking about x and y, our x is our hours, our y is our money. And this is generally true when you have a table. The top is the x, the bottom is the y. The left is the x, the right is the y. Okay, but that's your general rule of thumb, independent versus dependent. So I'm going to use slope formula to find my slope. And again, I'm just going to choose the easiest numbers I can think of. So I'm going to say that this is my y2 and my y1, which means this is my x2 and my x1. So I'm going to say -3 minus -1.4, because it's minus y1, over 0 minus 2. This simplifies to -1.6 over -2, which in a calculator would simplify to 0.8. Now, you can write 0.8 as 8/10 if you were going to graph it, or 4/5. There's a lot of things equivalent here, but you need to simplify it from that -1.6 over -2, because that is a sloppy fraction. So now when I write my equation, I would say y equals, and I'm going to choose the most simple option, and I prefer fractions, so I'm going to say 4/5. And that's x and -3, because it's a negative y-intercept. Same with the next one. I'm just going to choose these, but I'm going to do this one as y2 and y1, and this one as x2 and x1. So I'm going to do 200 minus 35 over 3 minus 0. That's easy, right? And 200 minus 35 is 165. If you do 165 divided by 3, you get 55. So my equation is y equals 55x plus 35. All right, last one on this page. The graph shows the linear relationship between the number of minutes Ingrid has traveled and the number of miles she is from work. Write an equation for the graph. So looking at B and C, I see that it's asking what's the rate of change, what's the y-intercept. So I'm actually going to start on B and C because I need to find the rate of change, or the slope, okay? And I need to find the y-intercept to write my equation. So it's a lot easier to go in that order. Now you'll notice both the x and y-axis jump by 3, and that's important because if they're equal, I can just count by ones. Here's a perfect point, and here's a perfect point. So my slope, I'd go down 1, 2, 3, 4, down 4, and over 1, 2, 3. So my m value is -4/3. That means my slope is -4/3. Now, if I simplified this, it would be -1.3 continuing, okay? Because what does it mean? That's miles per minute. She is getting 1 mile close, or 1.3 miles closer to work, because our distance is closing in, at 1 mile or 1.3 miles per minute. And my y-intercept is 24. That's miles from work. So before she leaves work, she's 24 miles from work, and she gets closer by 1.3 miles per minute. So my equation then, going back to A, is y equals, and I prefer fractions for my slope, but because this is a word problem, I don't mind 1.3 continuous x plus 24. Now it says when y equals 0, what is the value of x? So we're looking here at y of 0. What's the value of x? What does this point represent? So when y is 0, x is 18, and it represents how many minutes it takes her to get to work. I'm just going to write to work. All right, so 18 minutes to work, 24 miles. Going on to the next page. We're going to apply slope-intercept form, but first let's do a quick review. So my slope is my coefficient. Now, when I look at D, I don't see a coefficient. We'll talk about that in a second. And my y-intercept is my constant. Now, you'll notice I underlined nothing in B, and that's because I can assume adding 0 doesn't change the value, so my y-intercept would be 0. So I'm going to say m equals, my slope is negative 17. My slope is 3/4. My slope equals 0.5. And here, I don't have a slope, so I could include a plus 0x, and that means I have a horizontal line. So I would do slope equals 0. And then my y-intercepts, b equals -2, b equals 0, b equals 8, and b equals 9. Now we're going to draw a quick sketch of each graph. This would be a downhill line, so it's decreasing. This would be an uphill line because it's a positive slope. This would also be an uphill line because it's a positive slope. And this would be a horizontal line because it's a 0 slope. And I'm just going to write the word 0 because we need to remember that. Now, given the equation 6y equals 3x minus 18, Natalie believes that the slope is 3 and the y-intercept is -18. Explain Natalie's error below and show work in the box at the right to find the correct slope and y-intercept. So Natalie first needs to isolate y or solve for y. So we're going to write that down. Natalie, excuse my terrible typing, needs to first isolate y because it has a 6 attached to it before she has slope intercept form. Okay, so we are going to first isolate y, and all we need to do for that, this is just like a literal equation, we need to divide all terms by 6. So we have y equals 3/6 x, which simplifies to 1/2, and minus 3. So our slope is 1/2, and our y-intercept is -3. Okay? So that is Natalie's error. She had the right idea, but didn't solve for y. So let's look at a few examples where we'd have to solve for y first. Okay? So here I have a -2 with my y. So line down my equal sign as always, and I'm going to divide by -2. And you can just use your calculator for simplifying. Here we would get -9/2 x minus 12. So my slope would be -9/2, and my y-intercept would be -12, my constant. Now on the next one, I need to distribute and simplify first as well. So I still have y alone, but my equation is not simplified. So I have 7 plus 9x, because 3 times 3x is 9x, minus 12, because 3 times -4 is -12. And then I have to combine my like terms. So I have y equals 9x, and 7 minus 12 is negative 5. So my slope is 9, and my y-intercept is negative 5. Now the next one we have to do the same thing, but I'm going to distribute and then bring my negative 4 over. So I have y minus 4 equals negative 1/2 x plus 4, because negative 1/2 times negative 8 is positive 4. And then I'm going to add my 4 to move it to the other side, because I need to isolate y. So y equals negative 1/2 x plus 8. My y-intercept is 8. My slope is negative 1/2. Now it says, write an equation of a graph line below in slope-intercept form. Okay, next circle the names of any students who wrote the equation that also matches the graphed line. So what we're trying to see is that it doesn't have to be in slope-intercept form to still be a line. There's just a simplest form. Okay, so here, first, always check your y and x axis. My y jumps by 2, my x jumps by 1, and place your 2 perfect points. Okay, so my x jumps by 2, so I'm going to go 2, 4, up 4, over 1. So my slope is 4, because 4 over 1 equals 4. And my y-intercept is 6, so my b is 6. So I go y equals m, which is 4, x plus 6. Now, note Carlos and Sarabeth and Keegan do not have matching answers with me, but that doesn't mean they're wrong. So I need to simplify and solve by isolating y. So I have y equals 4x plus 6. Okay, Carlos agrees. For Sarabeth, we need to distribute, then combine like terms. So I have negative 2 plus 4x minus 6. So this is promising, but I still need to combine my like terms. So I have 4x minus 8. Negative 2 minus 6 is negative 8. So not Sarabeth. And then Keegan, we need to distribute, then move our negative 3 over. So 1/3 times 9 is 3. 1/3 times 12x is 4x. Y minus 3 equals 3 plus 4x, and then I'm going to add my 3 over. So y equals 4x, and then 3 plus 3 is 6. So Keegan also is correct. So just because it looks different doesn't mean it isn't equivalent. Go ahead to the back, and we're back to functions. The function f of x equals 7.5 plus 2.5 times x minus 1. It can be used to represent the total cost of swimming at a community pool for x hours. So right now I want you thinking, x is your domain, okay? The total cost is your range. It's not what it's asking, but think about that. What is the rate of change? So rate of change is slope. We're going to write that down. Of the cost in dollars with respect to the number of hours. Explain. So we really need to just solve for y, which you don't see a y, but f of x and y are the same thing. So I have y equals 7.5 plus, and I'm going to distribute my 2.5 out. So 2.5x minus 2.5. And really we could stop here because our coefficient of x is not going to change. However, for the sake of simplifying, I'm going to say y equals 7.5 minus 2.5 is 5. So 2.5x plus 5. Okay? So 2.5 is my slope. So it should be 2.5, and it'd be the cost, so dollars per hour is the x. Remember, y over x. Rise over run. So $2.5 per hour. Create a graph of each equation below. We're going to do our line down our equal sign and solve. Divide by -6, divide by negative 6, and it has to be on all terms. Y equals simplified to negative 1/3 x and plus 1. And here we do the same, except we're distributing, so y equals 2x minus 3. So we're going to graph. So in pink I have a y-intercept of 1, and I have a slope of negative 1/3. So I'm going to go down 1 over 1, 2, 3. And both the x and y axis are just jumping by 3. And then for the sake of it being straight, I'm going to go also up 1 and left 3. Remember, you have to go in the opposite direction if you're going up. Okay, so there's our line for A. And for B, I'd start at negative 3, and my slope is 2. So remember, anytime you don't have a denominator, it's 1. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Up 2 over 1. And I can also go down 2, left 1. Remember, opposite direction, because it should be a line. Okay, record the letter of the graph next to the equation that could represent the linear relationship. So my advice to you first is focus on the slope. If the slope is positive, we can narrow it down. If the slope is negative, we can narrow it down, but I do have to have them in simplest form. So here I would divide by negative 7 to move it over. So I'd have y equals negative 2/7, so that messed with our slope, right? So now I have a negative slope minus 35. Okay, so it's my y-intercept should be a negative, and then my slope is also a negative. So I'm thinking graph A is number 1, but we're going to use process of elimination here. Okay. Number 2, I have to distribute my negative 1.5. So I would have, let's see, negative 6x minus 15, right? Yes, so this time, oh, I just realized I made an error. In the one above, I have negative 35 divided by negative 7. That should have a positive. So I should be moving my plus 1. It should have a positive y-intercept, excuse me, here. So this would be graph C because it has a negative slope but a positive y-intercept. That means this one with a negative slope and a negative y-intercept, that would be A. And then B has a positive slope. Let's see, positive slope, but a negative y-intercept, so that would be B. So we can narrow it down. All right, we have just a couple minutes. Ted's coin jar has 150 or 45 worth of quarters inside. Ted plans to buy one 50-cent candy bar from a convenience store each day. Write a function to represent the value after purchasing X number of candy bars. So we don't actually have to write or solve an equation. It would just be f of x equals, he has $145, and then each day he spends 50 cents. So x represents the number of days, 145 represents how much he starts with. At Liberty High School, there's 32 desks in each classroom. One classroom has 3 desks missing due to damage. Write an equation to show the relationship between y, the total number of desks at the school, and x, the number of classrooms. So here, I'd have y equals 32 times the number of classrooms minus 3, because one of the classrooms is missing 3. Okay, finally it says Lynn's monthly budget is X dollars. She spends $2,250 each month on fixed expenses and half of the remaining budget to put into savings. Which function could be used to find the amount she puts in savings? Well, if she spends $250 a month, okay, we'd have to multiply half and then divide by 2. So here, these would mean the same thing, so it would be both, because multiplying by 1/2 and dividing by 2 are the same thing. Again, if you need to rewind, go back, pause, listen again because we went too fast, you are welcome to do that. Thanks for coming.